Okay, we're going to pick up from where we left off, and we were constructing a frequency distribution based on this set of 50 observations. We can assume their ages in years, but it doesn't matter. So what we're doing is we're taking this raw data and we're converting it into group data using this chart right here. So let's see how you did. If you add up all of the observations that are between 20 and 30, you should have got 6. Between 30 and 40, there are 18. Between 40 and 50, 11. 50 and 60, 11 again. And between 60 and 70, there are 3. And between 70 and 80, there was 1 observation. You can check your work and verify that it adds up to 50 observations. If it doesn't add up to 50 observations, then you've done something wrong and you need to go back and check and see where the missing values are. Then we can calculate the relative frequency. So to get that for each class, you take the frequency of the class and divide it by the total. So 6 divided by 50 is going to be 12. So 0.12. Then 18 divided by 50 is going to be 0.36. And then we have 11 divided by 50 is going to give us 0.22. These can also be expressed as percents, so those would be 22%. And then 3 divided by 50 gives us 0.06. And finally, 1 out of 50 is 0.02 or 2%. Again, you can verify your work. It should add up to approximately 1 or 100%. Okay, so moving on to the cumulative frequency. So how we do that is we start off with the class we're in. So the lowest class is 6. Then we add to it the class that we're working on. So it's the frequencies up to and including the class that you're on. So 6 plus 18 gives us 24. 6 plus 24 plus 11, or 6 plus 18 plus 11 gives us 35. Then another 11 gives us 46. So we're just adding these frequencies up. So the next one would be 6 plus 18 plus 11 plus 3 is going to give us 49. And then you should end up with 50. And that ends up being the same as our total. Then moving on to get the relative cumulative frequency, you take 6 and divide it by 50. That gave us the same as our relative frequency. And then 24 divided by 50 is going to be 0.48. And the next one is going to be 0.70. Then the next one, 46 divided by 50 is going to be 0.92. I can write it in there neatly. And then the next one, 49 divided by 50 is going to be 0.98. And then 50 divided by 50 is going to be the total 1. And that's how it should end up. And so these can also be converted to percent. So sometimes we see the relative cumulative frequency or percent. So those would be easily converted. So 0.12 would be 12%, 0.48 would be 48%, and so on. So we can look at see how this distribution looks in some plots. So we can look at the quantitative plots. And the first one here, we're using this data, is the histogram. And so you can see in the class interval between 30 and 40, we had the most observations, right? If you remember, we had 18 observations here. So the height of the histogram corresponds to 18, right there. And then, and I've added these little dots in, these dashes in here so you can really see. The first one here is 6. Remember the last one, there was only 1, it's the smallest. These ones here have a height of 11. So you can see the 11 there. Here's the 6. Here's the 1. And then the last class here has 3. So that is a histogram, and we can get a lot of information. It tells us a lot more than just looking at the raw data. We can see it is right skewed. We'll learn a little more about skewness and shape and center in the next chapter. But yeah, it tells us a lot about the distribution and how spread out the data is. So along the horizontal axis is the width. So we had 20 up to under 30. Right? 30 up to under 40, 40 up to under 50, and so forth. And notice these are all the same width. Okay, we can also plot the frequency. So look on the vertical axis here. We have the frequency. That's how often those observations occurred for each class. So again, we have class 20 to under 30, 30 to under 40, and so on. So I started at 0 just to make the plot look nice. So this corresponds to our frequency column that we have in our table. And this is the value 6. So what you do is you find that point in the middle of this interval. So the midpoint is 25. The midpoint between 30 and 40 is 35. And so you put the points at those midpoints. The next one would be, it's going to be 18. That's this point here. The next one is 11 and 11. That's these two. And again, they're right at the midpoint of those class intervals. Right, so remember how to calculate the class midpoint is you take the beginning point, add it to the end point. So if you wanted to know what that value is, you would take 30, add it to 40, divide by 2, gives you 35. And that's how you get the class midpoints. So they're right in the middle, and that's where those points go. So we have 6, 18, 11, 11. This would be 3 here, and 1, and then I end with 0, just to make the polygon look nice. So you can look at this and you can go, well, geez, how many observations did I have that were less than 50? And you can just add those up. You can look and see the shape of the distribution. Again, it's similar in shape to the histogram, but it has more detail because it's giving us how many's in each one. Although the histogram told us how many is in each class as well. But this is more showing we're just connecting the dots. So it's a different way to visualize the distribution. And then if you look at the vertical axis again, this time instead of frequency, it says cumulative frequency. So here we have what is called an ogive. And so it's going to be, these are going to correspond. So we have our first class, 20 to 30, and these are going to correspond with the endpoints to the column that was called cumulative frequency. So here we have 6, that's 6. The next one in the column was 24, and I'm putting them right with the 40, and then 50. This one here would correspond to 35, then 46, then 49, and 50. And you can get information from that too, so you can see what the cumulative frequency is of the data set. Okay, and the last one, of course, is the cumulative relative frequency, and it's also an ogive as well, but here you can see the cumulative relative frequency. It's our last column in our table, and again, they line up with, so here I just made it 0 to make it look nice, and then the next one would be, it's going to correspond to 0.12, this is going to correspond to 0.48, and so on. So the last column until you hit, and all of cumulative relative frequencies always end with this value at the top, 1.0. These can also, you could also have here percents. Sometimes we see it like that. And these are all quantitative plots, and there's one more way we could plot the quantitative data set. This is the same data set, 50 observations, and it's called a stem and leaf plot. They are not very common. These are the stems, and then these are the leaves. These are not very common because they're really only good for small data sets, 50 or less. If you have more than that, you would absolutely use a histogram, but these show the data and you can see the shape. So how we do this, remember the minimum value was 23. That first number there is the stem, and the 3 goes with the leaf. So the last number always goes with the leaves. And so you have 23, then we have 25, then we have 26, 26, 28, and 29. Here you can see you have 1, 2, 3, 4, 5, 6 30s. Also, 74 was our maximum, right? So that corresponds to the 7 and then the 4. So these are our class intervals, 2, 3, 4, 5, and 6. Those are our stems. And then the leaves correspond to the last number of the observation in the data set. So these are all quantitative graphs or plots. We use the word graph and plot interchangeably. And next we'll look at the next video segment, we'll look at qualitative plots and graphs, another way of saying categorical data.